Hello everyone, and thank you for clicking on the help video. So let's see if I could guide you through this example and you find again the mistakes you're making on your version of this problem. So here we have a chemical spill polluted river with a toxin concentration of 620 ppm, parts per million. Now natural water flow and filtering breaks down the toxin at a continuous rate of 9% per year. So what is the toxin concentration after 19 years? So first of all, let's talk about the formula. What's the appropriate formula here? Now, obviously, this has nothing to do with compounding, so we're not going to use the compounding formula. So we're left to the other two formulas. And in this one, because we are breaking something down, this number is going to be negative, and it's breaking it down at a continuous rate. So that means we have to use the continuous exponential decay or growth formula, which is either version is fine. A equals P times E times RT. And like I mentioned in today's notes, that's the exact same formula as this. This one is just more exclusive to compounding because P stands for principal. And this one is just a general version of that formula there, where A, the initial value, could be anything. Like in this example, it could be the amount of toxin that this river is going to have. So let's use that version of the continuous thing, but we have to use the continuous exponential situation. So the value of A is going to be the 620, at least in my example, and the R, also in my example, is going to be a negative number. That's going to be the same on yours because it's breaking it down. So that means that this amount is decreasing. So we're going to take away 9%. So minus 9 out of 100, which is negative 0.09. And that's going to be measured again per day. And the time is also measured in days, so we don't have to do any conversions. 19 days, okay? So now let's just plug it in. Evaluate that using Desmos. So the amount of toxin in this river is going to go down, which makes sense because it's breaking it down. So it's going to go down to 100.112. 112. It doesn't say to estimate anything, but I'm going to estimate to 2 decimal places. So 136. I'm going to look at the first 3 decimal places since I want to estimate it to that one. Using the next one, since it's 5 or more, I add one more, so 14. So there, parts per million. So there's your answer, 112.14. So hopefully this video was helpful to help you with your problem. So now try yours.